is our parallel programming language, and it will be converted into VM code. VM code looks like this. So it mainly works with our stack, which is a memory that when you want to add some number into your stack, it will be added from the bottom. And if you want to get the value from the stack, and it will give you the last value from the stack. And so if you convert this into VM code, it will not be like this. You can't write S1, Y, C. It will be different. So these are just set variables, arguments, local variables, and by this memory from your RAM, there will be allocated different memory locations. So you will have a space for the local variables, you will have a space for the arguments and set variables, and so on. And if you want to convert this into VM code, it will look like this. So yes. S1 is our static variable, so that's why it should be stored to the static space. And because S1 is the first time we have seen as a static variable, so we will store it into first cell of the static. So it will be replaced with the static 0. This comment means get the first value from the static memory segment and push into our stack. This will be replaced with the so y is the argument, one of the arguments from the function, and this is the second argument. That's why we are storing into second space of the argument segment. So we will replace with argument 1 because I starts from 0 and C1. So how to replace this C? C is our local variable, right? And this is a 0, 1, 2. So it's located into cell number 2. So that's why this will be replaced with a local 2. So let's look at how to convert this kind of instruction into assembly language. So, for example, push constant 17. This means take the number 17, cell constant number, and push it into our stack. So if our current state of the stack was like this, 12, 5, and it should be like this after our this comment push constant 17. So what do you think before this state? What kind of comments we did to have this kind of picture?
Push 12 to 5.
Push constant 12, push constant 5. For example, or might be something else. Maybe we got these values from other segments. So now our comment is this. So let's look at our RAM. This is our RAM, and SP means stack pointer. So it always shows you next empty cell. So to store a new value, our SP's address will be stored in our register 0. So it shows you where is our stack pointer. The base address of the stack pointer is 256. So if our stack is empty, SP shows you 256. So our first value to the stack will be added to this address. So we already have two values. That's why our current SP is 258. Okay. After doing this operation, we will have this kind of picture. So if it was 258, so our next stack pointer will be 259 because the next empty cell after 258 is 259. And in these addresses, you will see our step. Okay, this is just a pseudocode to convert from the VM into ASM language. So we just equalizing number 17 into the memory cell, which shows us SP. Then we are implementing our SP to show that next empty cell is next to our 258 cell. So let's convert it into assembly language. So first, what should we do? Let's take the number, constant number, 17. Using what kind of instruction?
X17.
Instruction 17. And let's store to some variable. D equal to
A.
because this 17 is stored into our A register, right? And let's select our SP. Now our A register have what value?
SP.
A equal to 0. This selects as the 0 register. But M equal to what?
258.
Now I should go to this 258